Thank you, Brian. Hi everyone, my name is Ian. I'm a software engineer at OSRF. I work on simulations, and today the title of my talk is Cloudy with a Chance of Simulation. So as you may have guessed, I'm going to talk to you about cloud simulations. A little bit of history here. Why are we doing simulations on the cloud? So it goes back to the DARPA Virtual Robotics Challenge, which happened in 2013. It happened before the DARPA Robotics Challenge. So this is the VRC where the competition happened in simulation. So we were asked to create this online centralized platform for teams from around the world to join in and compete in simulation. So they had to control the simulated Atlas robot to perform various tasks like driving a vehicle, walking on uneven terrain, and also manipulating tools. So this is when we turned to cloud technology. And it's also when the first cloud simulation tool was born. It was called CloudSim. So with the use of CloudSim, we were able to launch hundreds of machines on the cloud and provision them with our software, which is Gazebo and ROS, and then give them to the teams to use to practice, and also we use them for the competition. So with CloudSim, the VRC went well. And more recently, we've been approached by different other groups. They come to us, and then they also want to host and run competitions. So here are just a few. So we have the Space Robotics Challenge. It's coming up. SRC that's been recently announced. So the competition involves this Valkyrie robot. It will be performing some repair tasks in space, in simulation, of course. The nature of the competition is somewhat similar to the VRC, where you have one primary robot doing stuff in simulation. And then in the middle, you have the Agile Robotics for Industrial Automation competition, ARIAC. That involves a UI robot in a more industrial warehouse-like setting. So in this competition, the robot will be fully autonomous. There will be no remote operator interaction. And down the bottom, there is a upcoming Swarm competition. It hasn't been announced yet, but I'll just give you a little bit of details. So in this competition, there's the setup where there are two teams, swarms, and they'll be doing stuff in simulation. And so all these projects are very exciting. As we learn more and more about them, we found out there are actually quite a few different requirements, like how the competition will be run, who will be running the simulations, and how we're going to get the user code up onto these machines on the cloud. So, so that is also one of the main reasons why we're looking into developing a new cloud simulation tool. So it's called CloudSim.io. We're actively working on it. And the plan is that by sometime by the end of this year or early next year, we have something ready for the participants of these competitions to actually use and practice. So what's new in the new CloudSim tool? So the goals are still the same. We want to have a set of tools to help us launch simulations and manage them on the cloud. But underneath the hood, we actually wrote everything from the ground up. One of the main reasons for that is because over the past 2-3 years, we observed that the web and cloud technology has evolved quite a bit, and we really want to take advantage of all these new tools out there. So we decided to write everything from scratch. A quick overview of the architecture. So on the front end, we started building these web components. So we looked at all these different projects and all their requirements that we have, and then we identify a set of functionalities, UI functionalities that could be shared between all these projects. And then we turn them into these generic reusable web components that we can use to quickly piece together a new UI for different special projects. And on the back end, so we're moving away from more of a centralized approach to a more distributed one. We split up the backend server into multiple servers. So now we have an authentication server, we have servers who are launching machines, we have servers who are managing tasks that are running on the machines. So what you can see here is that we're taking more of a bottom-up approach. We create all these building blocks that we can take to quickly put together and make specialized web applications for different projects. And hopefully all these tools will be mature enough later on and will be released all to the public. In fact, they're all open source right now. You can download them. The next one is flexible configuration of machine instances. So back in the VRC, every team has a fixed cluster of machines to work with. They get a simulator, and they get a couple of field computers. That's where they deploy the code. So the walking controllers, motion planning, perception, whatever. And then we have a router to route traffic. But in the new upcoming clustering, we want to make that as flexible as possible. So we want users to be able to just launch any type of machines. It can be simulations, it can be field computers, and then let them group them together into one like virtual private network. We also support resource sharing, so you can share your machine instances like you would share a Google Doc, for example. And we also let them share on the simulation level. So sometimes you don't necessarily want to give users access to your machine, but you want to invite them to join you in the simulation, right? So they cannot SSH your machine, they cannot kill your machine, but they can come in and interact with you in the simulation. And then we're looking for different ways to help improve the process of getting user code up onto the machine instances. So here, quickly going over the front end. So as mentioned before, we're developing lots and lots of web components. Some of the key ones are highlighted here in green. And the web components on the front end talks directly to the back end, so there's no central place to route requests. So for example, on the top right, you have the component for logging in. It talks directly to the authentication server. Once you're authenticated, you get a token, and with that token, you can do stuff like launching machines by talking to the portal server in the middle. And at this point in time, you have one machine running in the cloud, but it's idle, nothing exciting is happening. So we support this notion of creating and loading tasks onto the machines. So down on the bottom there, we have a widget for creating simulation tasks. So these tasks would be things like, for example, ROS launch my gazebo with an empty world, for example. And so with this widget, you can load various tasks onto the machine instances. We have a server to manage it, and then when you run it, it just executes that command and then brings up gazebo or any other your ROS launch scripts. So just quick overview of the workflow. So you log in, you get a token, which is very common these days. With the token has your user profile. You use it to talk to the portal to launch a machine. It will verify if you have permission to launch a machine. If you do, we launch a machine for you. And then once the machine is up and running, you can start creating tasks. And once everything is up and running, we can get status back over WebSockets. So you can see that your machine is running, is being terminated, or is terminated, or it's in an error state. And the next feature I want to talk about is security groups. So what security groups are just basically control the traffic between instances on the cloud. So I want to show this with respect to upcoming Swamp competition, which motivated us to add this feature in the first place. So in the Swamp competition, we have this setup. So we have the blue team, and we have on the left, we have the Go team on the right, and then they need to interact with the simulator. And then we also want to prevent them from listening on each other. So we want to prevent cheating. Right? So we want to make this configuration to set up as easy as possible. So this is intended for competition admins. So what they can do now is just to create a group called Blue, and then you launch your instances in the group. We have default configuration set up so that all the machines in the same group will be able to communicate with one another. And then what they need to do next is just create a role. that says I want to allow incoming traffic from the simulator or the simulation group. And then we open up all the necessary ports for that to happen. And now you have the machines in the brew group. You can now subscribe and publish to topics advertised by the simulator. And with that, I would like to just show a live demo of some of the features I've been talking about. So again, we are actively working on Cloudson, and this is the current landing page. And I'm going to show things like launching machines and sharing machines. So I'm going to log in as an admin. We're using Auth0 for our authentication service provider. By the way, this is our dev server running somewhere in the US. And here we have a very simple UI. We will expect the UI to be to evolve quite a bit as we add more features to this. So you can see in the middle we have a widget to launch machines, and there are a few options to choose from. And down the bottom we already have a machine running. So I started it before the presentation. I'm going to use it very soon. But here I just want to show you the process of launching a machine. Just hit launch, you get some notification down there, and a new entry appears, and it has a status that it's launching. So the machine has been brought up somewhere on Amazon in the West Coast, Oregon, I think. And then we get an IP address here. So now the machine is booting up. We have widgets to create these simulation tasks that I talked about. We observed that it actually takes around a minute or so for the computer to fully boot up. So that's why I have a machine down here on the bottom that's ready to go. And with this, I wanted to show you creating tasks. So I click the add button, and I already have a demo set up. With GZ demo, I will add the task. And for now, we just execute this command automatically. So you see it's spinning, it's running, the process has started. What GZ demo is just, it brings up Gazebo with an empty world. Very, very simple demo. And with this, hopefully the internet connection allows. And now we are in our simulation. So this is GZ Web. For those of you who haven't seen, this is our WebGL front end for Gazebo. It has a subset of the features as the desktop version. It doesn't have all the model editors and building editors that you saw yesterday morning. Those are great features, but we want to keep this as simple as possible for now. Right? So now we're in simulation. We can interact with it. You can insert simple shapes, you can insert lights, you can also insert models from the model database, quite a few. And we also have a scene tree, so just like GZ client. So I'm just gonna quickly insert a box just to show you. You can inspect them. Oh yeah, you can also configure physics params, but I wanna inspect this box that I just added to see the post data. Oh. I guess someone also accessed the simulation and added this the sphere over there. Yes, someone was waving their hands. Yeah. So you can collaborate with your team members if you want. Yes. Yeah, so we need to secure this. This is something we need to add. Yeah. Okay, so I just want to show you that everything is running up and live. There's physics running, so if you rotate your cube, you can see the values here. So yeah, so everything is live learning. We get all the data back over WebSockets. So now you have this great simulation you want to share with your friends. Or prevent people from joining. Okay, so I want to share with myself, which is, I'm just going to type in my username here. You can set the read-write access level. So I'm gonna add, and then I'll get this little notification that pops up. And then I'm gonna log in as Ian. Take some time. All right, so now I can see this machine that I just been that the admin has shared with me. So I don't have a widget to launch a machine because I'm not an admin, but I'm just a user, regular user. I can go in there and open up WebGL, and then saw, yep, someone was playing with the cylinder over there. So yeah, so you can see that you can now access the simulation. Okay, so because I have write access to this machine, I can just kill it. And now I just say terminating, and you go back to the admin view, and you see that, oh, it says it's terminating as well. So everything is in sync. Okay. I'm just gonna close this, and that's the demo. So future work. So it's work in progress. We're actively working on it every day. There's the upcoming competitions, of course, that we have to get it done, right? So the competitions require different versions of ROS and Gazebo. So we want to make this as easy to configure as possible. They should just be able to select the version of ROS and Gazebo, and then everything should be set up for them. There's a little bit of work to do on the WebGL front end that you just saw. We recently had a Google Summer of Code student that contributed to integrate a new backend for us. And then now we need to work on things like improving performance and stability of GZWeb. There's also traffic shaping, which is a feature that we had during the VRC that let us limit bandwidth and latency between machines. We hope to bring it back. And then for the competitions, we need to implement a leaderboard. But in the long term, what we're hoping to end up with is just a set of software libraries and packages or tools that for the community to use for any of your cloud simulation needs. You can use all these packages to create your own custom cloud sim if you want to, or you can just use a subset of these tools to just launch simulations on the cloud whenever you want to. So an example there would be GZWeb. We've heard quite a few groups have started using it, which has been developed as part of our cloud effort. So for example, in the next talk, we have the construct who will show probably, hopefully, some of their stuff using GZWeb, and then they're using it to visualize their cloud simulations. In the longer term, we think that simulation on cloud is generally really good for continuous integration testing. Powerful ways is to spin up machines on the cloud, test your entire software stack, and get results back. And then for things like training and education, so we've held workshops before with CloudSim and GZWeb, and it just really takes the hassle out of us from preparing all these, setting up all these laptops, putting in our luggage, carrying our luggage, and taking it to a workshop. With CloudSim and GZWeb, you can just launch machines and then deliver your workshops. For things like, also, everything is configured for you. If you're new to ROS, new to robotics in general, so you can just launch a machine with everything set up for you. You don't have to worry about Kepken workspace, and then you focus on learning the core robotics concepts right there, and then solving the actual robotics problems. Another idea that popped up recently is just have something like interactive ROS tutorials. For example, you have these code snippets, you run them immediately, and then you see the results as you're learning. And with that, that's all I have. Thank you very much. It's not on, I think.
Ooh, this one's on. Excellent. So CloudSum seems really cool.
Yep.
For advanced ROS users, do you think it would be possible to have a workspace on your Ubuntu workstation and then network to CloudSum and see the interaction between the two?
Yes, I believe we can do that. We can just export the right ports in for you. You get a SSH key. You can log on to. You can log on to it to configure it if you want to manually. Otherwise, you can just open the ports and then you can start your ROS node on your local client and then connect to the machine up on the cloud.
Cool.
Yeah. Anything else?
Well, we're actually a little bit over time, so we'll take the rest of the questions offline. Thank you.
Thank you.